cheese.
So I've been collecting quite a few batteries. And by quite a few, I mean this is just this month's batch. So I've been testing, and separating all the batteries that I get. Because I'm making a battery. I'm making a battery big enough for what could be an electric motorcycle. Though in my case, it's going to be a moped. Now, this was the original design for it. It was gonna have two plates, so top plate, bottom plate, about that thick, about this big. I was gonna make it super fancy where you could just slide it in, twist, and it'd be locked in place. Had most of the designs ready for that, but I decided later on that I'd go to a different plan, just to make it simpler to fix, just in case I ever needed to. So with that out of the way, I've now got myself in a dilemma. I don't have anything to make the battery with. And I definitely don't want to just be soldering each one of these because heat will definitely affect all these batteries. So that's where this comes in. Got myself a high voltage microwave transformer, little bit of 4-gauge wire, and some welding terminals. So I'll get started here. I've got to take off the secondary coil, wrap this instead, and then begins my journey on making a low voltage welder. Alrighty, did a little work off camera. Just tried to clean it up a little bit more. All the coil for the secondaries out. So now it's time to see if I can even wind this thing. I doubt I'm going to get more than like 3 coils in. Alrighty, time for the first test run. Finally found an old power cord that I wasn't using for anything. I'm going to give it a shot. Should be enough for at least this short test. If all goes well, I should only have a couple volts. So, got the welding glove out just in case I've got to pull the plug real quick. Definitely not going to go near any of the main terminals on the secondary. So let's see what happens. I am getting 2.3 volts, which is pretty much exactly what I was hoping for. So, I am going to flip everything around and try to see how many amps I'm getting through that coil right now. So I was having a little bit of trouble determining the amperage that I was running. I was able to figure out that this thing's using about 5 amps without load, but I can't go any higher than 10 amps on this meter. So I bit the bullet and finally got an amperage meter. So I was able to learn a couple things, so let me show you. So these are pretty simple to use. All you have to do is set it to amperage. right on there. Check your mode here. So I am going to be working fairly low amperage for this. One thing I never really considered before buying one of these is you can't just go over to a cord, clip it, and see how much amp you're running, because the hot and the neutral will counteract each other. So you have to do it on an isolated line. So like here, again, I'm getting about 4.5 amps, like I expected. Now again, that's no load, so I can't just hook it up to here. It's really not going to give me anything because, you know, nothing's running through it. So unfortunately, the only way to test to see if this is actually pulling any amperage will be to connect the two poles together. Now that being said, once I do this, I run into another problem. So it's only running 2.2 volts. Now, if I test right here, when it's running, it's going to say it's overloaded because, you know, it's more than 400 amps. And I've already figured that one out. Now I can pop it on here again with the load to see how much amps we're running, which I'll show you here in just 1 second. So now, as I expect, we're getting about 11, 12 amps. Now, I was actually getting 15 amps earlier, but that just might be how I have the wires clipped together right now, which I'm going to undo for safety reasons. But that pretty much determines what I needed to determine, and I think this will work, so I'm going to have to rig it up to a tip, which I've actually got one pre-made here. These are actually parts of another welder that I had, but didn't work. So, we'll see what happens. I spent a little bit of time getting the controller right. Sort of stole the design from another creator, but all the code is technically mine, with exception to one line. It's kind of neat. So that's the amount of milliseconds that it'll turn on, and it turns on this relay. It's a solid state relay. It should work up to 25 amps. So that's good. And then goes through here. And I've got this hooked up to here for testing purposes. But I realized there's a little bit of a catch. So I can press the button. That little light will light up. Though my switch is kind of funky. It doesn't want to work all the time. And here, let me plug it in. And as soon as it goes off, you can hear the transformer. If I get the button right. There you go. For just a second. Now, I know these wires will output more than 400 amps, but through these, I'm assuming a 10 gauge wire here, it's got a little bit of a hiccup. So let's set it to max. So I'm barely pushing out, I'm not even pushing out half an amp. Yeah, so that's not doing anything, but let me show you something. So what I got here is just for troubleshooting, just to see my amperage go up. So when I turn it on, let's turn it on a couple times. There you go. Yeah. And it does my 400 amps right there. So yeah. So that concludes this part is definitely the issue. So I just got home from work and I've been playing around with it for just a couple seconds here. And I'm actually happy. I've got a couple parts that I've ordered to make an actual new holder for this. But I literally just kind of set it up like this, which I do not recommend at all. I just wanted to make sure that I was right. And yeah, well, the one wasn't holding on there really well, but yeah, it 100 milliseconds. It actually welded onto there. And let's see. it welded on and it barely did any damage to the battery itself for that limited amount of time. So, I mean, that's progress. I like that. I'm happy with that. This was my attempt at a new set of tips. Although I still think I have a major voltage drop going on. I got them on 6-gauge wire rather than the 10-gauge wire I had before, but they're still not doing great. And because I made these tips, I went ahead and I set up a foot pedal. It's actually a Rock Band foot pedal. Got it hooked up kind of janky, but it works. As soon as I press down on the foot, it works. Fixed the other one I had because that one was kind of, the button was unreliable. But let me show you what I've got. So with this current setup, I've got to set it to ½ a second, which I really, really do not like. And because I use regular THHN type wire, the wire is really, really stiff. So it does weld. It's still not the greatest weld. Actually, that one even popped off right there. Granted, I have been messing around with that one. This is a weld that I did previously. And, you know, it's still not great. So this is 0.1 millimeter. This is what I want to use. This is 0.2. And as you can see, it doesn't go through it at all, no matter what I try. So I'm going to do a little bit of an upgrade. So I got the 2-gauge wire on, but I still am pretty disappointed. Tried hooking it up to the original 6-gauge wire tap here that I had, and it still had pretty poor results. Even doing the bare bones setup, it still will not weld this 0.2 millimeter. Of course, it does do a little bit better on this 1 millimeter, or 0.1 millimeter. Still takes me a good amount of effort to pull that off, but that's still not good. So I think I am going to try to find me a bigger transformer before I cut this wire off, because I want to get like 2 or 3 more winds on this, because I barely have, it's really just one wind. Maybe consider it 2, I'm not sure. So I've made some more progress, and although it's a pretty excessive solution and slightly more dangerous than what I had, I think it'll work for now. So obviously this guy is the same. I went and bought 4-gauge welding wire, which I actually found for cheaper than the other place I was buying stuff, so it wasn't too much more expensive than what I already had. Now, although I'm fairly certain, but not 100% positive, that this is a 120 volt setup transformer, I did hook it up to 220, which actually had to run out and actually hook up a 220 plug in here anyway. Now, my only other concern is at the moment when I'm running tests, that is the amperage coming off of 220. It's quite a bit. Now, the other thing that I'm a little problematic at is while it can do some really great welds with the 1 millimeter again, this is the 1 millimeter, 0.1 millimeter. This is the 0.2, which, after a bit of finagling, it does work. And it did take ½ a second to do this. It still, with a little bit of force, will peel off. So it's usable and workable. It's just not the perfect solution at the moment. That being said as well, being that I'm kind of overloading this transformer a bit, it's warming up. Again, not the greatest solution in the world, so I won't be able to just use it over and over and over again constantly. So it'll be kind of a slow process until I get a better high-powered transformer. So now I just have to make the case, and I drew this up in CAD and marked off where I need to cut, so now I just got to cut it and assemble it and clean it up, and we'll see what it looks like here in a second. Alright, we're skipping a little bit forward on here. This is what I've gotten so far. I actually decided to stick a fan on this too. I've still got to grind out and do the rest of the holes for there. 3D printed out a handle. Vent hole, did by hand. Pretty much just kind of set that in there and went at it. But the frame is going to be mostly disassemblable. Oh, and I left a screw on there. Using inset rivets. Now, the way I bent this was pretty obnoxious because, for the most part, I just took a pair of pliers and bent it into shape, and then used my my vise to kind of just clean it up a little bit. Used some spray paint on this one that I had lying around, but I actually don't like the color, so I'll try that again. But yeah, I will cut to when it's finished. Cut to about a week later when I finally got this thing finished. It does not look bad at all. Actually, it looks like a real device. Got me a on and off switch, a power plug. Can open up the top. And everything is wired up, ready to go. Now, I did have one problem. The solder on this connection over here failed, so I had to resolder that. The fan is wired up directly to a 5-volt plug. Hopefully it's not going to overload. I do have a fuse hooked up to the 12-volt, or I'm sorry, 5-volt USB power adapter, which I just have kind of in place with the wiring, and got a little bit of shrink wrap on there. Everything is grounded. Now, one thing I'm not 100% sure on is it is rated for 20 amps, this plug here, but I'm not exactly sure on these little components that came with it. I'm just going to run them because I'm pretty sure they're just filters. Until it explodes, but it is rated for 240 if it needs to be, and it should be fine. So let me get this all closed up, and we can do some work. Okay, so the first thing I established is this is alright for 0.1 millimeter nickel strips, but it's not really good at all for 0.2, and 0.2 is what I'm going to be primarily working with. So this is the best I had at the time, but since I've been working on another project, I ended up finding this and doing the exact same thing that I did before. So instead of this, now the wire in this, I don't even know what the primary winding is, to be honest. It's probably something close to like 16 or... Man, I don't even know how to judge anymore, like 18 gauge. While this stuff looks to be probably close to 14 or 16. So it's a lot thicker of a primary winding. Now, I didn't have as much room before to put the 2 gauge wire that I wanted in, so I only had 4 gauge for this one. So these have the exact same amount of turns on the secondary winding, but I've got 2 gauge instead of 4 gauge, so I should be pumping out quite a bit more current. So I'm going to go give this a shot and see if it works. Okay, now with all that extra power that I now have, I don't think it's a particularly good idea to be holding both of these with my hands. So even with a heavy glove, I'm just going to have a new one with heavier gauge wire that I can just hold with the single hand, that I can kind of just stamp on and not have to worry about anything. I'm also going to use welder wire because THHN is really, really hard to keep using like this. So we'll go ahead and build that real quick. So I finally have the new transformer hooked up, and I've run into a couple of problems so far. First off, my original solid state relay was only rated for 25 amps, and immediately after putting this thing on 220, it blew the relay and set it on full on. So got a new one rated for 80 amps. Put one of these metal oxide varistors in place to hopefully save it from dying if I have a problem like that again. And unfortunately, the next problem that I have is this thing pulls enough juice that I can't use it when my brother's awake because his uninterrupted power supply shuts his computer down because it thinks there's a power outage. So that's fun. Alright, well I think that's good enough. It's going to work from now on. So, I did make some upgrades. The copper in the tips were particularly soft because it's just wire coppered, it's annealed copper. It took me a minute to figure out how to harden copper because you can't just heat it up and quench it like you can steel, because that actually makes it soft again. But what you can do, and I'll pop it up here at the top of the screen, is you can hit it with a hammer and that hardens it. For whatever reason on copper, that just is one of the ways to harden copper. Another thing I did is inside the tips, I put some oxidization guard to keep it from, basically keep it, the corrosion between the copper and the aluminum from making it lose contact. So hopefully that will help in the long run. So the batteries, it took me a minute to figure out how much pressure I was supposed to apply. Because if you don't apply enough pressure on the batteries, it will actually burn a hole through the tabs, and if you put too much pressure in, it'll kind of melt into the battery, which either way is awful for what I'm doing. So now I think I figured out the pressure. It seems to be working all right. And I think I can pretty much start using all these batteries which I've accumulated, which since the beginning when I showed you the batteries that I had, I now have like twice as many batteries that I have been given. So now I've got to go through the process of recycling them, sorting them out, and doing all that. But unfortunately, like all these little battery cases that I had been experimenting with, my 3D printer broke the other day, so and it broke in a way that is not going to be good because I just happen to have one of those 3D printers where you can't really get the parts, and the parts that you can get are like $200 or $300 for whatever reason. So it's either I'm going to buy a new 3D printer or I'm going to really rewire the whole thing. So that'll be an adventure, but that'll be for another video. Thank you all for watching, and I'll see you in the next one.